The mass production of humanoid robots has finally arrived. Claiming to beat Tesla to the punch, today we will be showing you the first humanoid robot factory capable of producing 10,000 robots. The robot's called Digit is created by Agility Robotics. While the market for robots with a humanoid form factor promises to be extremely nutty, and there'll be room for many vendors, the real key will be the company that can mass produce robots that are functional and that have purpose. To help us understand all of this, we're joined today by Scott Walter. Scott has co-founded 2 robotics companies in the past. Thank you again, Scott. Really appreciate you. I love it when we do these bot videos. Thank you for joining me.
It's great to be back, Herbert.
So this topic, you and I have been approached by several people saying you got to do a video on this because this is the first announcement of a mass-produced robotics factory. Let's kind of share a little bit of what we're talking about. So this is Digit, and Digit is a humanoid form factor, but I could see, and you and I have done another deep dive on this robot before. It doesn't have hands, but it's very agile, and it actually is able to walk quite nicely. Agility Robotics is opening a humanoid robot factory, and they love to say it, beating Tesla to the punch. Why don't I go ahead and show the video of the announcement of what they call RoboFab.
This is a really significant moment in the robotics industry. This is the world's first humanoid robot factory. This has never been done before. It's a brand new building, about 70,000 square feet, and it'll be able to deliver over 10,000 robots a year at max capacity. It's roughly 30 miles from our engineering center, which is fantastic. Not only that we're building it in the United States, but also that we're so close to the rest of the team. The other thing that's really exciting is that Digit's going to work in our factory too. So just like Digit helps our customers in the logistics and warehouse space, we have logistics and warehouse needs as well. Digit's going to move totes in our factory and help move material around the production floor. There was a point in time over 100 years ago when we had the world's first automobile factory. I think this is the same moment where we're now having the world's first humanoid robot factory. And someday, just like automobiles, humanoid robots will be all around the globe. And it's fantastic to be a part of that journey.
I do like that, Scott. What do you think? Why don't you make a comment about what we just saw? Then I'm going to show the actual Digit robots as well.
Okay, well, I think the first thing is there's been a lot of skeptics out there about the Tesla bot and what's it good for. And the thing you have to realize is that there's a lot of other companies out there chasing this exact same dream, and they've been doing it for longer than 2 years, some of them 6, maybe 10 years or even longer. And while a lot of them have shown prototypes, none of them have decided to take it to the stage of mass production. And that's already been done. And so I would say this is actually bullish for Tesla bot and humanoid robots in general, because it means people are actually serious about it. So you've got another team out there that's figured out how to design a humanoid robot that can be mass produced. And I assume mass produced for a reasonable price. We don't know what the price is yet, but I'm sure they're also cognizant of the fact that people don't want to have to spend too much money for it. And they believe it is useful in some sort of niche. So you don't decide to build a factory if you cannot make the case that you need to produce 10,000 robots per year. Now, caution you is the facility is going to be completed at the end of this year, which I think means they're going to start putting in the first production equipment, and it can scale up over some point to 10,000. So it's not like next year they're going to be producing 10,000 bots, but they certainly are envisioning to be able to do it at some point during a normal kind of ramp up phase. And that's a fairly big number, but I would say it's not overly aggressive, because if you break those numbers down, you say a 50-week year, then that's about 200 a week. So that's like 40 a day. And if you're doing 2 shifts, that's about 2.5 an hour. So the production volume is achievable. They'll be able to do it. And they're actually also doing it in a much smaller footprint than you imagine. So, 70,000 sounds like a big number. And so I always try to figure out, well, exactly what does that mean? Roughly it means half a Super Walmart or half a Costco. in square footage about that, if you look at the average size of those. The other way to put it in perspective is a American football field is 57,000 square feet. So if you start to include the sidelines, everything else in there around the field, that surface there is 70,000 square feet. So they're looking at in an area about the size of a football field to be able to mass produce 10,000 robots a year. And this is something we've been saying again and again, that when it comes to the production of Optimus and others, is you don't need something that big. I mean, you literally could go into a shopping mall, and shopping malls are made up of, super Walmart, stuff like that, and find some empty warehouse space in there and almost convert it overnight to start to be able to do this kind of production. So those are some of the first takeaways that I've sort of seen from that to get an idea and the excitement that, someone is doing it. Now, to Agility's credit, they're not going out and like saying, aha, Tesla, we beat you to the punch. That's the mainstream media deciding that's how they have to write the headline for them, okay? So let's not take that away from Agility that they've gone ahead and done it. And I think the other thing that we'll find out when we get in the articles is that, the people they've hired to do this have experience in this particular area. They know a little bit about production, so they know what they're doing. And Tesla likes competition. They like to be out there. And Elon, he never likes being in second place. So I almost feel sorry for the rest of the team because you know what that means.
Okay, well, a couple comments.
Talking to.
Yeah. You and I have done quite a number of videos on the bots. We've done one on the top 10 robots. And at that time, you had said that Digit, as well, I'm going to show the video, it's a very capable bot. It's designed for very specific tasks, which you will show us. What tasks will Digit do that maybe Tesla bot or others will do? They're not competing per se. First of all, the market is so massive that it doesn't almost matter how many vendors out there. It'll be years before they bump into each other, and it's who can produce billions of this before you can actually get to the point of not be able to sell your bot that you create. But we will walk today about how the different form factors, they call it digits, but you pointed out that they actually don't have digits, the finger digits, but very capable. And so it was between this one and what's the other company that we thought was a good one?
Sanctuary.
Sanctuary,
Sanctuary. And then you have we looked at Fourier. There's also Unitree's come out with something.
But those others, other than
is another one. Yep.
Other than these two that we're talking about, Tesla bot and Digit, maybe one or two others, the rest, they look great, but they're just really demos. And that's what's interesting about this bot, because it's happening. So let's go watch the actual bot in action and see it actually very, very functional.
How to make a robot that can go where people go, do useful things in a world designed around people, and navigate the human world. That human-centric approach takes a real depth of understanding, knowledge, and experience. It's one thing to build a robot that looks like a human. It's far more challenging to build a robot that moves like a human and captures the same physics to enable the same performance.
Human-centric robotics is challenging because our space is relatively unstructured compared to being able to design the environment around the robot. And so as robots get a little bit more intelligent, that's certainly a really necessary piece of it. But the other piece of it is the physical interaction. When you build a robot that's able to go where people go, that's something that Agility has really pioneered and excels at.
We have so much complexity, so many things that come into play. And we want Digit to be able to interact with all of those things and handle them dynamically, handle people in situations and totes in unknown locations, things like that, and be able to still do its job safely.
This new iteration of Digit is a culmination of over 2 decades of research and development. Now it's time for us to take these robots into the real world and deliver value to our customers, eventually paving the way to general-purpose robots that are part of our everyday life.
Our dream is to build robots that free us from robotic tasks, that enable humans to be more human. And everything we've built, every breakthrough, is part of the journey towards that goal. And that's where Digit is going. Digit is made for work.
Okay, Scott, I do have several questions to ask you that I want to point out. So first, of course, let me just share the photo again, just so we can see what this Digit looks like. Very, very capable, can do lots of things. But we should point out that while it's humanoid, it can walk to places. Doesn't have the fingers that we talked about, but it also
Right.
may not actually have a brain. Look how small that, not that the head size matters, but they don't ever talk about AI and the ability to teach it, and we don't know how intelligent this is. Can you speak to that before we go back to the factory?
Yeah, it's sort of hard to know at this point. I know that they're talking about using large language models and others to help them to teach digit and do some training. So I'm sure there's some AI back in there, and I don't know how much of that is built directly into the bot and how much of it might be, let's say, part of some sort of cloud that you use for it to connect to give it
Yeah,
instructions on what to do next. So,
but
there's some good question marks there. I don't know.
but the Agility Robotics does not have a supercomputer, and they're not known for
Correct.
machine
Correct.
learning,
Correct.
AI, and
Yeah.
real world autopilot that Tesla's doing. I just want to point out, I'm not saying that they don't even barely talk about it. So I'd really
They
be
may have
curious how you teach
access
it.
to one, like a lot of other companies, but they don't own one directly. Yes.
Yeah.
Now, the other thing to sort of point out about it is that it doesn't have it doesn't have fingers, so it has hands. But if you look at the application of the internet, you see, you don't always need fingers. So there are a lot of applications you can do without fingers. In this case, it's looking for the logistics in the totes. And you notice those totes are not specially designed for digit. Those are the same kind of totes that you're going to see out on the factory floor. And again, Jonathan Hurst is right when he's talking about that we don't want to have to design the environment around the robot, as the robots can be designed for the environment we're in. So again, he's got the right approach. It is nice to see the digits a little bit taller than your average human as far as being able to go up in there. And this, if everyone remembers when we did the deep dive, they literally built those robots from the ground up. So they started with the walking problem and literally just the legs. And it came out of research from, I believe, University of Oregon, of a bipedal robot that was like all it was. There was no torso, there was nothing else, and still holds the world record for the fastest bipedal robot, which is like 22 seconds for the 100 meters, which means Usain Bolt is still a lot faster. Usain Bolt can go over 200 meters in the same amount of time. So, so it's pretty good speed. I'm not sure I can do the 100 meter in 22 seconds anymore. So that's not bad. And then they tried to figure out, what do we do on top of this thing? So we figured out the walking part. Now everyone noticed, like, wow, those legs look kind of weird. And it looks like an ostrich, and an ostrich is a type of animal that its walking gait is considered a digitigrade, because it walks on its digits. And what you think are its knees are actually its ankles. And its knees aren't backwards, its knees are just up very, very high. And so that's where the name digit comes from, which at the same time is kind of weird because it doesn't actually have digits as far as fingers. It's the digits on basically the toes, that's what's more or less walking on, as opposed to walking on its heels. So they figured out, a solution and a niche that they could go in to do it. And it's a niche that you definitely need in a lot of manufacturing scenarios. And they're going to try to discover that in their own factory by saying that, well, we're going to try this in our own factory. And I think it will work kind of in the sort of the volume production that they're looking at, that it probably will actually be a very good fit for what they're wanting to do. And it will fit a lot of smaller manufacturers and maybe medium-sized manufacturers. Larger manufacturers, it may in a few areas, but not throughout the whole plant. There's many of other solutions that it would compete against that will probably be better, that we can talk about as we go along.
Okay, let's cover some more information. Thank you for sharing that about digits. So just to cover the facts here, so 70,000 square foot facility, you talked about it. They're calling it RoboFab.
Yes.
It's going to produce 10,000 units maximum capacity. It's going to employ 500 people, but you said they're going to also include their own robots in there. Funded by DCVC and Playground Global Investors.
Yeah, so they have some capital that have looked at the market and everything else and decided it's a reasonable investment for them to go into. It is venture capital, which is always a little bit risky, but they see that this has potentially a very big upside, which is really what venture capitalists look for. They don't so much look at the downside. I mean, they're aware of risk. They realize, like, yeah, this could just go under. But boy, if it really works out, it's going to be a home run. So that's why they're looking in that particular area. And now it's like the first one to go from that initial sort of venture stage of like build a bot that can do something and we can demonstrate a little bit, to them actually going into production. So they're way ahead of like almost all the other competitors out there, no doubt about it.
And I'll say
It
that.
has been mentioned in the articles of, how far ahead they are of Tesla. We don't know that, Tesla might also be ready to pull a rabbit out of the hat by the end of this year to say, yeah, we're ready to produce. We're ready to set that up.
Well, like
So
we said,
it's going to be an interesting competition.
it's not a competition.
Yeah.
It doesn't matter how fast these guys go. They will sell every bot that they make. And
Mhm.
it's going to be, you will tell us later exactly what specific roles it can do, and it'll fit those roles very nicely.
Yes.
So let's continue on and compare the differences. So in that article, of course, they kind of downplay the fact that it does not have five-fingered hands. And we've said already that when you have five-fingered hands, that allows you to use tools that humans use, like a drill and
Correct.
others, and can bake and open ovens. This one won't necessarily be able to do that per se. And it looks like more like a claw mitten. And then what they said was, look, when I see robots that have five fingers, I think, oh, great, someone built a robot, then they built two more robots onto their robot. And then they're saying, you should just have a hand that is no more complex than the need for the job.
Absolutely correct. I agree that you shouldn't pay for more than you absolutely need. And there's so many niche applications that you can do. I mean, a lot of times you begin to realize that if you've ever sprained your wrist or something like that and you have it all wrapped up, you'd be surprised how many things you can actually do in the house without even using your fingers, and in some ways not having full mobility on your wrist. Of course, you can't do assembly, you can't do fine detail. There's going to be a lot of things it's excluded from. But it looks like they're saying, we don't care about that. There's all these other tasks that we know we can do now. We're not waiting to figure out how to get the fingers. And eventually they'll try to get there probably, but we can also do it for much lower cost. So they're gradually building up the platform. Actually, the arm has way more degrees of freedom than I initially thought. When I started looking, I said, wow, because I used to have a 4-degree freedom arm. So the first early ones we saw, and I'm looking at it, it's a full 7-axis arm. So they've actually got the famous yawing in the hand, which I thought, oh, you don't need that for picking up totes. And I was looking at it, holy cow, they're actually using it. So they've actually designed the full arm for that. And by not having the fingers, there is one big advantage is if you look at all the other bots, including Optimus, you'll notice there's all this external cabling going around. And none of them have figured out how to route the cables through the arm into the hands without having some big loop or something like that. They're all there. And when you look at Digit, there are no exposed cables. That's something that really amazes me. It looks like there is absolutely nothing there. So they have figured out how to do that, which is a big step. The other big thing is those arms that are on there are very cobotic in nature. They are designed to work around humans. And in fact, I think somewhere in the article, they talk about it being kind of a co-worker. Mm-hmm. So basically collaborating with a human right next to them, as opposed to necessarily working completely by themselves, which is what we would be thinking Tesla about and others. It's like they're going to go over to a station, they're just kind of working there. They're not working next to me or something like that. They're actually doing the whole job. So in order to do that, they have to be really sure that this robot is designed in such a way that's not going to injure anyone that they have to be near.
Yeah, and it's tiny, as we said. Okay, the other last bit here that's quite interesting, you pointed out, Agility prefers to actually sell, not rent or lease. And they believe that first partner will receive it next year already, but they're going to sell it. So yeah, talk about that.
Yeah. Now, I have the impression that there probably have already been other partners out there that have been using it because they have these videos and everything to show what to do when you get your Digit and how to put together. They've been out there for a few years. So I think there's been definitely a lot of beta testing and everything else, but I've never seen any real numbers on what it's going to be. I'm pretty sure it's south of 100,000, and I'm guessing in the order of 50 or something like that. I could be way off. No one really quote me on that, but I'm assuming it's sort of in that area. And it's really interesting. They said, we're going to sell these things. And of course, our thesis all along has been that Tesla, probably in the early stages, would only end up leasing. And I've had other people in comments and Twitter, stuff like I say, no, they don't think so. They think you can go to a sales model, and that's all right. I don't mind the pushback because it's a kind of discussion, and who knows, they might change their minds as well. They may somewhere along the way say, wait a minute, we're leaving money on the table. Or it might be that, sure, we're selling it, but there's a maintenance package that comes along with it, which a lot of people will do with software anyways, and in order to maintain the bot and everything else, and then maybe they're looking at other services. So you never know. Sometimes they call that like the Trojan horse. You get that in the factory, and then they have a hard time running it. It's like, well, bring our techs in, and our techs will come over and help you out. So, I'm sure they're looking at some sort of financial model that makes sense for them, that they'll be able to keep profitable. And of course, we could be completely wrong about Tesla because Elon has stated, yeah, you'll be able to buy it for $20,000. So maybe Tesla is really going to sell it right from the beginning, and there won't be a leasing model, which I know some people don't quite understand a leasing model. We're talking more about like a rental, or what I should really call a robot as a service kind of model, that you just, as you need it, the robot comes in and they take care of everything, and you train it for what your task need, and they do what they do to make sure that robot keeps functioning.
I do think that there's a big difference as we're comparing Agility Robotics with Tesla. Tesla's basically massive company with tremendous amount of revenue and profit and cash on hand. They don't, they can basically fund this like crazy. Agility needs to fund this. They've got VC funding, yes.
Yes.
But they need to sell the robot to get that money right as cash as fast as possible. They may not be able to survive if they leased it slowly over many, many months in the future. Do you know what I'm saying?
That could be another good reason is the cash comes in as opposed to, okay, $50,000 lease per year or something like that, like we talked about Tesla bought, but that's coming in monthly. It's not like right up front. And so if you need that immediate cash infusion, and because they can change their model whenever they want, depending on how it's going. But you're right, they're in, that awkward position that all the others are in, is that we're in this constant R&D phase, and we've got to create a product, and then we have to start showing a profit, because eventually the venture capitalists are going to run out of patience and say you've got to start producing something. And Tesla doesn't have to do that because they can self-fund this for a long, long, long time. And of course, we've talked about they don't have to sell it because the internal benefits will pay for itself. So if they can knock the margins down on the products that are producing, they're going to be fine. So that's why they can take a little bit longer, and there hasn't been this rush to get to production necessarily. But I'm pretty sure, Elon pretty much said they'll be ready to scale by the end of November, because they're ramping up the most complex part, which are the actuators. Everything else is really pretty simple. Some of the other things I'm wondering about the RoboFactory is like how much of it is actually manufactured internally, where there's more of an assembly shop, and how much of it is coming from suppliers. So I don't know if they have like on-site plastic injection molding for a lot of the housings and everything else around there, I would think they go to supplier, because you can knock out 10,000 parts really quickly. And it's better to go to a parts house that just does that. And, we'll knock it out in a couple of days for you and send it to you. Now you got the supply that you have, as opposed to you having something sitting there idle most of the year. So they're going to pick and choose what they are doing internally. The actuators I don't know about. Now, Elon has made this big thing about you cannot come up with a compelling robot without some sort of custom actuators. But it seems like everyone else is using maybe their own, or using what might be off the shelf, or maybe they're doing it on their own. So I haven't heard from Agility to know whether it's their own. The thing that's interesting is that Digit is known for being able to walk very well, and obviously very quickly. And you look at the size of those actuators compared to what we see on Optimus, and they're very different. And I still haven't quite figured out why one is like really big, or why the other one is really small. And one of them has found the right answer. I'm not sure who it is.
Okay. Tell me the differences between the use cases that we would see Tesla's humanoid robot versus what we would see Digit. So start off with what is Digit designed for?
Okay, so the Tesla bot can be, first the low-hanging fruit for Tesla bot we've always seen as being more of like parts loading, of being able to take parts out of bins and then move them over to somewhere else to feed a cell or something like that, and potentially be able to do small assembly tasks and stuff like that, because it has the fingers and it has the dexterity to do it. Now, there are the bins that the parts come out of. So Tesla bot has the capability to bring those bins from one part of the factory over to another if it wanted to. Digit can do that as well. Now, maybe Digit can do it for a little bit less, depending upon what the cost is of building the two bots. So since you don't need the fingers to be able to do that, a lot of these totes are going to be moving around, because logistics inside the factory is very important. So we know Jeff Lutz talks about how important logistics is in general for a corporation, but it doesn't end at the loading docks. It's like in some cases, the headache almost begins at that point, because now you have to warehouse all this stuff, and you have to figure out how to efficiently and quickly move it from one part of the factory to somewhere else, depending upon what the particular needs are. And there's many ways of doing that. We know in factories, the most famous way, everyone's like, there are these forklifts that just keep on picking up pallets from somewhere and dropping them off somewhere else. But then there's a lot of other situations where you may then be taking these very big containers and stuff gets taken out of it, and now it has to be sent out to somewhere else. So you can think of the factory as having like arteries and then, you know, smaller arteries and capillaries and everything else. And at that point, you have these smaller cells where there's still material flow that's going on. And you can solve that many ways. And like I said, forklifts is one way. Another way is you can use like an autonomous robot or a mobile robot to move them around. You could be using some sort of conveyance system, like, you know, a conveyor, overhead conveyor, something like that. Or you could use a human that's just grabbing and playing the role of what I like to say is a gopher. So, you know, here's an example I like to show of what it's like to move parts from one side of the factory to another. Now, what I want you to think of this is like two shorelines on a river, okay? And you need to get stuff from one shore over to another, and you've got a lot of ways of doing it. And depending upon how much material you have to move from one side of the shore to another, the best way might just be able to come up with a ferry of some sort that is going to shuttle it across. Or you go ahead and decide, well, wait a minute, we've got to move a lot of things across the river. Let's build this really big bridge. And that's the conveyor system. But when you do that, the consequence is now your boats can't go down the river anymore. So you got to figure out, yeah, I got to build a drawbridge, or the bridge has to go very high and everything else. So depending upon your needs, you may use one of these different kind of solutions. The different solutions we're looking on here is that it's one thing to go from one side of the shore to another. You have to also think about getting the stuff onto your boat or the mobile robots in this way and getting it off. And one way is that you might have a built-in conveyor on the mobile robot that we see there, where things basically roll on and roll off.
I see.
The other is if it can't roll on and roll off, you can always build a robotic arm into your mobile arm to do that. But the problem is that takes power away from the mobile bot. The arm is used on both sides, which is nice, but a lot of times it's just going for a ride doing nothing. So that could be a waste, especially if you say, well, I need to get a lot of stuff across, so let's have 10 ferries running at the same time.
Let me
servicing the same docking ports if you want. So what you can then do is say, well, wait a minute, let's make the bots, those arms that are going to be moving the things around, and make them stationary at both sides. And that way I could have a fleet of these mobile robots going between the ones which are the stationary bots that are sitting there, those arms, and just loading and unloading. And we see that typically in a lot of other places. But a lot of times you may have a situation where that arm is sitting there not doing anything for a long time because it only needs to work maybe 2 hours of the whole day. So 6 hours is sitting there doing nothing. Just move it to somewhere else where it's needed. Yeah, but it's bolted to the floor, you know? How do you do that? So then you end up saying you could deploy like a humanoid robot to do the same task. Because what Optimus becomes automation on demand. So if that loading and unloading task does not have to permanently be there, it's not something constantly going on and on, it's just occasionally every now and then, it'd be nice to have a bot that's kind of deployable. And in that case, that's how you're using the legs of Optimus. Or let's say for some reason the AGV is not able to get in really close to it, then Optimus might have to walk a few steps, in which case it does need the legs. And finally, and this is what I think they're really thinking of having Digit for, is Digit to be able to sort of pick up from one location and bring it to another, so it can pick it off the conveyor and then walk the whole way. Now, that's not necessarily the most efficient use, because these mobile bots will probably be faster than a bipedal bot. And also they'll be able to lose less power, stuff like that. But it depends on the distance. So you have like short haul, medium haul, long haul. And depending upon that, you're going to have different ways of sort of moving your freight around.
Okay. Yeah, no, I appreciate this. It took me a little bit to explain what I'm watching here. So let me explain to folks if they hadn't already seen it. So the first one is a conveyor belt, like you said.
Yes.
The second one is actually a mobile bot like this, but it actually is a conveyor belt itself. So when it gets to here, it'll just use a conveyor belt. This one here, the third one, it actually has a robot arm on the actual bot itself. This one here, the robot arms are on the tables. And then I don't know the difference between this. Oh, this one is a humanoid robot is on the end, and then it'll grab it and move it. And the final one is just a humanoid robot by itself. And so that's what we're watching.
Right. Now, those two humanoid robots are basically doing the same thing that the two fixed traditional robot arms are doing there. And so, you know, the question is which is the best capital outlay? Now, those two arms that you see there actually will probably end up costing more than Optimus, even though it's a single arm. So in some ways,
you should know.
It's going to be cheaper to go ahead and do that, and almost easier to deploy. And again, if it's the type of thing that, you kind of need it over here, you need it over there. And if you look at a lot of factories, it's just like that. They'll get this worker to say, you just pick up the stuff off over there right now. And they work there for half an hour, and then they need to go over to there, and then they need to go somewhere else. And that's why sometimes what looks like a really easy task, it's not automated because it's just not used enough. You need to have the ability to deploy a resource very easily, and humans are the easiest resources to deploy. They just walk around, go over there. So that's where Optimus can come in and will have the ability to be deployable to where it's needed at a particular point. And so what I see is happening is that if you get a factory that has a fairly high volume, it's extremely high volume is going to be lots of conveyors. I mean, if you go to Procter & Gamble, I don't think you're going to see any mobile robots there because stuff is just flying through so quickly. And conveyors is almost the only way to do that. When you have like lower volume of movement of stuff, then you're looking at different ways of shuttling it around. And it used to be, it was always done with forklifts, but now they're going more to mobile robots because they're a little bit smaller. You can have a bigger workforce of them, but they have to move at a safe speed. So fork trucks can usually go a little bit faster and sometimes can take like much bigger pallets. But if you need to move medium-sized things around, they will be all right. And then, it sort of comes down to when in a factory would you just have a human worker literally go over and pick up totes and bring them over? Because it's just not worth putting in a mobile robot or the distance is very short. And you have a lot of factory settings like that, which you might say, well, rather than having the human has to go for, let's go ahead and have a humanoid robot to do that. And Digit will be perfect for that. And for the volumes that's coming out of their factory, I mean, you're looking at, if they want to hit 10,000, that's like 40 bots a day, probably over 2 shifts. It's only a couple an hour. So that means the amount of parts that you're moving around is not so great and of such an important nature that it wouldn't be able to be done by Digit. So I think they're looking at it that way, that it's sort of a perfect fit for them. And it depends on their warehousing. I mean, sometimes you have these warehouses which are huge. Okay, they're really big, and stuff is up very high and it's off somewhere else. And in order to get it down to the mobile robot that's going to move somewhere else, you have these big cranes. They're automated and they're kind of robots in their own right, but usually people just call them a crane. That's going to fetch some big part and take it down and drop it maybe onto a conveyor, and then the conveyor is going to go over to like a little loading station. It's going to look like a loading dock, and then maybe a mobile robot will pull right up there and will slide right on there and then get zipping off to somewhere else. So there's a lot of automation, a lot of pieces in there. You get to a smaller parts manufacturer, they don't have something big like that. They've got a much smaller kind of warehouse, which is basically the shelving that you saw in the first video we looked at the Pro Map, where Digit was taking the totes out. And you'll see a lot of factories just like that. It's like, here's our parts, here's all the stuff we need to have. It's accessible, people can get up in there. Sometimes they have to stand on a stool to do it. So Digit's able to reach, I think, maybe up to 9 feet or something like that. And so that's very, very common. Someone just needing to take that thing out and maybe bring it over to a conveyor system like that, but they're just kind of showing that you can load a conveyor. But a lot of times it's bringing it from there over to a particular workstation where someone wants to work. And if we go back to the initial video of the RoboFab, towards the end of the video, they showed, right after the clip with Ford in the manufacturing line, they showed a workstation where someone is assembling Digit. And so it's going to come right after this. We're going to stop the clip right after this. We'll see the operator. And what you're going to see, stop right there. You see those little totes that are kind of up at the top? That's all the material he needs to be able to put it together. That's coming from someplace. It's somewhere else in the factory. So it's either something that was produced in another area that now needs to come over for him to do it, or it's something that they purchased from a vendor that they have a large supply of it, and it's sitting in kind of a little, what they might call a supermarket, inside the factory with the stuff. And it needs to be brought over at a timely basis. So someone needs to do that internal transportation. That's what they're looking to have Digit do. And I think it's a great way to learn the capabilities of your own product. And the way you can improve it is make sure you are also a user of your own product. So that's how I see them using it. And the reason why I say that is because they actually said that, I think Adrian said that. That they plan on using it for the logistics within the factory to be able to move things around. And it's not, it's a kind of a niche market, but I wouldn't say it's a small market. Everyone needs this. There's a lot of small manufacturers out there just need to have stuff moving around. And it doesn't just mean manufacturing. I mean, this also happens in commercial properties as well. It's like you get the back end where there's like a lot of stuff in there that's going to be brought up to the customers in front. And so it'll be able to do a lot of things back there. And so long as it's not something that requires hands, if it's totes, it'll be easy. If it's picking up a bottle of something, that might be a little bit trickier.
Okay. And you should know because you have been a co-founder of two robotics companies, which are these usually the large industrial ones that basically grab and place, grab and place. But even then, very complicated. Your company designs,
Yeah,
figures this out, codes the code to make sure it does it right. And so that's what you were saying. Even the little guys, if they're just putting on the end there, that costs money too. The
yes,
beauty of the
yes, and
humanoid is that they can adjust to whatever environment you have, and they should be able to adapt to that scenario.
right, right, and there's a lot of applications like out there. It's like that looks so easy. It's like why haven't they gone ahead and automated it? And it might be that it's harder than people think. Or another that someone sent me yesterday is that evidently Maker's Mark, which has a very automated line for the bottling and everything, the very
Yeah,
end of it, it's hand dipped
yeah,
in the wax. And it looks like, well, that's real easy for Optimus to do. The problem is, I think they say that like it's hand dipped on the wax. So if you get the robot doing it, they won't be able to make that claim anymore. So that's probably the only reason the people are there. Because I was looking and said,
sure.
it seems like you could automate that already. You don't necessarily need a humanoid robot, but yeah, if you want to have it hand
Okay.
dipped, that's how
Yeah,
you have
sure.
to
Why
do
don't
it.
you walk me through some of the other videos that you prepared, trying to
Okay.
explain the differences of where they can work? Tell me which one you want me to
Yes.
pop up first.
So the first thing is the video that you saw there is on my my YouTube channel, which is a tiny little channel. It's Going Ballistic Motion, and so I do a 10-minute overview of exactly. It's called Optimus as a Gopher, and if anyone is like I think what is it, Minnesota Gophers, University of
Yeah.
Minnesota. I use the logo of the mascot on there because it's kind of a joke of what a gopher is someone that has to go for this and go for that. And so I give a full sort of narration on what's going on there for that explanation. Now I sent you a couple other things which aren't actually videos, but they are animation playbacks that you're able to do that you were able to load about an hour ago, correct?
Mhm.
And
There you go.
yeah, this basically can run on like an iPad or an iPhone. And this is the famous, Optimus feeding the cuckoos at the robot zoo. So this is the simulation of that, where we show the kinds of low-hanging fruit that we believe Optimus and other humanoid robots would be doing. And we've been, for the most part, been proven right because that's exactly what Elon said it was going to do early on. It was going to be loading the parts into the traditional welding cells. So you have a humanoid going around there. And it turns out you can actually zoom in and rotate around if you want, Herbert. You just kind of put your mouse over there and hold it down and just, do whatever, and you can change the viewpoint. So it's
Okay.
not actually a video. Yes, it's completely interactive. And if you, I think
Wow.
at the middle, so, okay, it's on a Mac, so I'm not sure what the buttons are, but if you use like what's the scrolling button, you should be able to zoom in and out and click in and get there. And not only that, there's a VR capability of this. So you could jump in there and look
Okay.
at that in a virtual reality kind of setting. So that's
That'd
sort
be
of one
awesome.
example that we've looked at. And there are other variations on a theme of loading these cells. So I
Mhm.
think there's another one I show that's also loading parts. Okay, so there again is showing the
Yeah.
gopher as an animation if
We
you
saw
want that you
this
can
already.
interact
Yeah.
with.
What
Yep.
else?
And then let's see, what's the next one that's there? I think there was another parts loading that we had, which was loading bigger parts. Let's see. Okay, this is a really big one, I think. This is the ball bearing production, and part of what this is showing, once it looks like Minecraft right now, but eventually it gets to have high resolution. There we go. So this is showing a lot of the different internal storage systems that you have in a company. So you have all the shelving where things have to go. Sometimes they have to reside there for a little while, or just a way to store it. And eventually, when you kind of get in there, and you can even take the scroll bar down the bottom and pull it to get more interesting area, and you can zoom back, I think, with your scroll bar and get a view of the whole factory. These were some of the examples I wanted to bring in to get an idea of, where something like a bot like Digit might fit in, because you see you've got a lot of the flow that's going on in here, and you've got, in the back, you've got something where, okay, in that case, a forklift needs to bring it because these are really big piece of dungages that need to be brought in. And then once things get broken down, they get into smaller pallets that have to move around to go into another residence area. In this case, they have automated cranes that go in and move everything and store it to get it into position. But at some point, it gets broken down to the stage that it may be that there's a human which is moving some of these totes around. So again,
Yeah.
if you look at what those humans are doing, it's pretty simple. That's not necessarily something you could do without having fully formed hands, So, that might be something more like what Optimus would be able to do. But there would be the movement of some of the material of any totes or pallets that could potentially be done also by Digit. And so you'll see different factories that do things like that. And this is like another example also sort of showing the much smaller storage system in the back, sometimes called an ASRS, where we have these boxes coming in or these pallets coming in, being stored, and then needing those cranes in the back to move them around. And eventually they get taken out and then dropped off at those different sort of loading docks for these mobile robots to bring them around. Now, there's no reason why that could not be done also by a humanoid robot, depending
But
upon the distance you have to travel, the how heavy it is, and it could pick it directly off the shelving rather than having to have that silly crane there, depending upon how big that is. So if you imagine scaling that down, you'd be able to say, oh, yeah, the Digit could be dropped right in there as well.
but this is like what Amazon does, and it looks in a warehouse. It looks like pretty effective.
Yeah,
It's already working now.
it's
So
similar.
why do you need?
Now,
But
Amazon
that's
is even
Amazon.
crazier because, I mean, those things are huge. They just have to store so much stuff. So again, I
Yeah.
say it's a thing with scale. When you have big scale, you've got to have those big cranes and all these other kinds
Yeah.
of solutions. You've got so much stuff moving around.
Gotcha.
And
Smaller guys. Yeah.
but when you get something that's kind of lower volume, where your shelving is basically designed for humans to be able to grab something from and move it around, and you want to automate that, you don't want to go to the place. Now, this is like really upscaling it. I mean, this gets closer to what something like Amazon would want to do, where there is
Okay.
no humanoids around here at all. You've got these very large cranes that are going through. I mean, it's almost imagining like a Costco where you have the the very
Yeah.
big storage that's going on in the warehouse, but even bigger than that. And so you have these very large pallets that have to move around, they get stored, and then when they're demanded, they get pulled out. And then, here's, other examples of that where you have different degrees of automation going on, of pulling from different areas of storage within your factory. So a lot of times they go from very big warehouses to kind of smaller areas, smaller buffers that then feeds another one. And there's a lot of automation that has been brought into these systems. And at some point, there's sort of like an interface between, well, how do we actually get it to our assembly cell where the humans are? Do we bring that over with a little small mobile robot? That's one solution. Or could it be done with a humanoid? And it's going to be a question of cost, capability, and ease of going ahead and programming. And it all depends upon the throughput that you have in your factory. What's going to be the best solution for you?
Love it.
Yeah.
Okay. So those are the different
Yep.
variations. This one is for
Yeah.
Optimus, or what is this?
Yeah,
one
this is
specifically?
one, when I was at Giga Texas, I saw a cell almost identical to this
Okay.
that wasn't operating at the time, but it's very clear what was supposed to happen is that they needed to put the tires onto this conveyor that then goes to the station that actually puts the tires onto the car. And they have like this big area just sitting out there where the tires are dropped off. And so, there'll be the different spec tires that have to be there. So obviously you have to know, I need to grab 4 of these or another 4 of these to make sure the right ones get out there. And the tires are very heavy to move around. So they already have what's known as a lift assist, just like that an operator would go over, grab a tire and bring it in. So, okay, that was what I called the low-hanging fruit so low on the ground, it's rotting. I mean,
Gotcha.
it's just easy. There's no precision involved. And
It's an
even that
example
lift
of
assist is designed to come over and so easily grab the tire, and then you're holding these, you got these buttons on here that will allow you to lift it up and move it around and handle it. You do need fingers for that. You need to be able to grab. And what Digit can do is Digit's got a flat palm. So they talked about it being like a claw or palm, or a mitten. That's not quite right, because even with a mitten, I can do this. So they basically have a flat surface that they can move around like that may be a little bit hard to operate something like that, which is why you would need some kind of finger controls. And that's the whole idea that Optimus is trying to be the simplest hand. Optimus's hand is somewhere between Digit and what we're seeing from these other bot manufacturers that are trying to go all in with fingers that have 3 joints rather than 2 joints, and different length fingers and all these others, and sensor pads and all that. So in many cases, they may be over-engineering what they're trying to do in the hand. And Optimus is like right in that sweet spot. It's like good enough to be able to do exactly what we want to do in the factory. And it will improve over time, depending upon the needs as they see it. But as Elon says, you always take the parts out until you have to start putting them back in. So why do we put touch sensing under fingertips if we don't know whether we need it? It might turn out we don't need it. Turns out we do. Okay, let's put it in.
Okay. So this is an example of this exists today in a factory. It's
Yes.
designed for humans because they don't have,
Mhm.
they don't have robots yet, and they use this lift assist. And so now, if you put in a humanoid robot that replicates it, you can take exactly what you're doing and replace it now, as opposed
Yes.
to
Yes.
the other versions that we talked about. And because of the tires being placed in different locations, you can't just take an existing bot that's go from one place to another place like you showed me at the very beginning. This is very, very specific.
It's
Um,
specific. There's different pickup and drop off points. You need the lift assist because it's very heavy, and it's too heavy for humans. It's also too heavy for a humanoid bot.
right.
But if you look at that, you would say, "Oh, wait a minute, that looks like a big Cartesian robot. I mean, why do they can't just automate it that way?" And I've seen areas where they do have these big Cartesian robots that do that. The problem is that suddenly becomes a big exclusion zone. No one's allowed in there, and you see the forklift driver has to constantly come in to do those particular deliveries. And so part of it might be cost. It may be not as easy to, it may seem like it's easy to automate, but it just doesn't have the flexibility. So it's there already. It's set up to be used by humans, and the decision was made, we're not automating that. They're just going to pick it off. They're going to like read what they have to do and then be done. And if you want to automate it right now, just throw Optimus over there. And then if Optimus doesn't work out, just throw the humans back on over there. So that's the beauty of it. A lot of times you put in automation and it fails and you don't know what to do. And it's very difficult for the humans to come in and save the day because the cell is designed for humans to be in there. And this was another example we had showing of Optimus loading, again, a welding cell, but with a much larger part. And again, a part that's too heavy for Optimus to be able to handle. So you have a lift assist. It goes ahead and moves around. And the cycle time is like well within what you would think Optimus should be able to do. And you see there's sort of two stations that we're loading there. And I suppose if for some reason in that case, it's picking from the same area. So really one Optimus has to do. It's not like you could get away with two Optimus to feed those two, unless you actually had two places where the parts are put down to feed each of the different cells.
This particular video is very, very similar to the video you and I saw of the Tesla Shanghai factory,
Yep.
where there was a human. We watched that person go into cages like this to feed massive robots like this, exactly like this, except it didn't need, in that case, they didn't need the lift assist.
Right, he had very small parts.
Yeah.
Yes.
But it was like,
Yes.
I'm just trying to tell people that this is existing in Tesla's factory all over the place. Every time we saw that video, you would say, see that guy, see that guy, see that guy. They could all be replaced.
They can all, yeah. And there's plenty. And again, if you look at, some of the earlier simulations that we just looked at there as well, where you saw that you had a stack of parts and an operator had to go over and pull a part out of there and just go over and drop it onto the conveyor and just go back and forth all day. Again, very easy, low-hanging fruit right there. And there's many, many applications like that out there that we can see in the factory that's ideal for a bot like Optimus. And you're going to see the same thing, is there's going to be plenty of these applications that are going to be ideal for Digit. So again, I don't see that they are necessarily competing. They're more or less complementing. And the market is so big and wide open. And it's great because Digit is very friendly looking. People just like the look of it. They're not intimidated by it. And what we want to do is we want to make sure people, love robots. So, we love robots. That's what we're trying to do here. Okay. We want to make sure that they're not going to be afraid that it's going to be a Terminator. And again, if you look at a couple of those articles that were out there about it, they're talking about, oh, is this going to replace workers? And it's like, no, it's filling in the workers that we can't find right now, because there are all these jobs that no one wants to do. We've got an aging boomer, generation that is now going into retirement. So we might have a smaller workforce. So we need to have more and more of these bots to fill in these jobs that we cannot fill in right now. And in many cases, they will make other people's jobs easier. And I was on Dirty Tesla's live stream last night, and he put it as, he said, it's the end of work. And I said, no, it's not the end of work. It's the end of toil. All right, you can still work if you want. There'll be plenty of jobs out there that if people want to do it, they can. But it's going to be jobs people actually enjoy. So it's not a job anymore, right? What's the old saying? A person who enjoys their job, it doesn't work a day in their life.
Mhm.
So that's what you really want to make sure is whatever it is, it's something you do because you actually get something out of it. And occasionally, yeah, these jobs might be a job, out of desperation because you've got to do something. But a lot of these jobs are not careers. And that's the idea, is like, get the bots going in there doing the stuff that people don't want to do. Let's get rid of the toil. And now let's make sure that people do the kind of work that's a bit more exciting and motivating. And they want to get up in the morning and show up for work because it's fun to go there, and they enjoy to see the benefit of the work. So again, we get people that make clay pots, right? We don't need people to make clay pots. I mean, there's plenty of automation to be able to kick those things out. But there are people who do it because it's like a passion. They absolutely love it. And of course, then there's people on the other side that are like, well, I want the one that's actually handmade and not, made in some factory somewhere. So there will always be that. There will always be the artisans to be doing these different things. And so it's not like suddenly work is going to be illegal and not allowed. It's just going to be, kind of optional. And I think most people are going to choose to have some form of, I wouldn't necessarily call it recreation, because sometimes you feel guilty if it's all recreation. You feel best at the end of a day where, like, what do you say, an honest day's work. You've gone out and you've really done something and you feel good about it. And that's what I think a lot of people are going to do. And now they will be able to do those kind of jobs because these other jobs they have to do that are more chores that they have to get done, so they can do the other thing over here. So, end of my spiel, end of my soapbox.
Okay. So what we talked about today is this is the very first, mass-produced robots. They're building the factory. It's going to come out by next year. You saw Digit. Digit is very capable. It's specific for certain jobs. You pointed out which jobs it can do and which ones it can't. But certainly there's going to be at least 10,000. There's going to be millions of jobs specifically
Yes.
for Digit. This is historic. This is a moment in time when, can you believe it? We're living in a time when robots are being mass produced,
Yeah.
humanoid robots. And the part I just keep trying to remind people is that this is going to be useful for many things, but it's not going to be the killer app, the killer bot, because it can't necessarily think. There's no brains attached to it yet. It's just a physical form factor that can probably do a very limited kind of like from here to here. But that's enough. That's enough to sell. This thing will sell like crazy.
It is.
And when we compare bots to each other, you pointed out that there's three things you need to look at, right? Whether or not how agile it is, if it can actually bipedal walk and go from one place to another, it can balance and all that. That's great. The second thing is hands. If you can have digits in your fingers, it allows you much more ability to do. You can grab a bottle, you can, do a drill, you can grab a cable. Not everything can be done with pinchers that we saw here.
Yes, it's
and
a
then-
bit complicated. I suppose if you wanted to get a bottle, and because I don't have one around here, if I want to try to pick this thing up, the way I could do it with flippers, I suppose you'd have to
Sure.
kind of do it like that. You'd have to use two hands. So if Digit's going to be working in the restaurant, it's going to be kind of interesting. It's like,
Well, I can't
Digit,
pick a fork.
Go
Can't
bring
pick up a
Herbert
fork.
his drink, and it's going to be, oh, here we go.
So it's not going to be designed for everything. And then the third thing
Yes.
is it's got to have a brain. And the brain is not just, coding it, which I
Yes.
think this particular Digit right now is coded, is my understanding would be the case. I know you said they have an AI division, but Agility Robots is not known for, again, a supercomputer with machine
Yep.
learning and data and so forth. It's probably coded like many bots we've seen, like even Boston Dynamics, as people don't realize it, it was 100% coded.
Mhm.
It was coded to do what it was supposed to do. And then it looks like it can do so many things, but it was told to do that, and it did exactly
Right.
those steps.
And my suspicion is there are like neural nets in some areas of like the perception system and everything else, but then there's probably also these heuristics that sort of tie everything together that might do a little bit for the planning of the motions and everything else, and that's okay.
Yeah.
These toolboxes are just going to get better, and they'll learn from it. Their customers will learn from it. Society will kind of learn from what it can and cannot do, and yeah, it's exciting times, huh?
It's exciting times. And then, of course, the other component that we need to think about is that Agility's got funding. They've got a factory. They're going to build it. But again, that company doesn't necessarily have expertise in manufacturing. They're going to start and work on it today. Again, the difference between Tesla is that they are a manufacturing company And so when they do stabilize and decide on a particular form factor, they won't only just produce a million, I mean 10,000. They're going to produce
they'll be
millions
able to ramp
quick because this is what they
because
do. They do this
they
now.
know what it's like to ramp really complex products, and
Yeah.
they've gone through it enough times they can do it. Obviously, Agility has brought some people in from the outside that have been part of that process in other places, but still, there's nothing like your organization going through it for the first time. So, they designed it for 10,000, and they said, eventually it will get there. So it's not like in December they're just going to turn it on and it's going to be
They
able to
did
do
say
that.
that.
It's
It will
going
take
to
time to
take a
scale
while
to 10,000.
to ramp it up.
And
But
also,
that's okay, because I'm not sure they have 10,000 users out there yet. They're going to have to get a couple of thousand out there first, and then people get really excited and then say, wow, that one we bought is great, 10 more. And then then the guy across the street looks what he's doing and says, yeah, I want some as well. So at some point they're going to do it, and I'm sure that's part of their business case, is that we need to be at 10,000 at some point. And of course, in a minute 42 video, you can't bring all those points across. And even the CNBC article, while it had some details in there, there's still a lot of stuff we don't know, like the price. We know they're going to sell it, we just don't know what they're going to sell it for.
I love the Digit. I think it looks great. I think you said it was a 4 feet tall. Is it 4 feet?
No, I think it's like 5. I think it's 5'8" or 5'9". It's actually pretty tall. It's one of the taller ones there.
Oh,
yeah.
Gosh.
Yeah,
okay.
yeah. And the other thing is when it stretches, it gets up there. So the question is, how do you measure how tall it is? Because
Gotcha.
I think it might be like an inch
The
taller
knees are bent.
than Optimus, and but Atlas is like 4'11". Atlas is the short one, and then the others kind of come in around 5, 6, something like that. But as you can see, when he gets way up on those legs and gets those arms up there, he can get up there. So he definitely has a better reach than 50, probably 90th percentile, 95th percentile humans. So no doubt about it. If your humans are able to get that tote down there without getting up on a step ladder, chances are Digit will be able to do it as well.
I think it's just really smart what they built.
Yeah.
It looks great, looks simple. I think we talked about another company. We looked at it and it was like so complicated. Hips are this big and lots of cables and so forth. This is very, very well designed. They're going to sell this.
It's svelte, and I don't know how they got it that svelte, really. I mean, and they got all the cabling hidden in there, and they got a 3-axis wrist, which impresses me and how they worked it out. I thought they didn't need that. And then I was looking at how I was grabbing the totes and I realized that little yaw actually comes in kind of handy, especially when you're trying to grab up really high. You get up really high, and then you need to kind of get the hand in there to be able to grab the tote the right way, so when you bring it down, you can do it. So it turns out that they studied it and realized that that little movement in the wrist that we think is not important, yeah, maybe it's going to be important. Let's figure out how to put another drive in there. And they did it. And they get the other drive in there, and they still hid the wiring. I have no idea how they did it. So I'm impressed. I really am impressed.
Okay, well, thank you so much for doing this with us, Scott. This was fantastic. This is a company to watch, right? Agility Robotics, Digit. It's exciting. They're going to make 10,000 of them, and hopefully that it's going to change the world. This is the beginning.
Yeah.
Okay.
Yeah.
Thank you, Scott. That was fun.
Okay.
Appreciate you.
Yeah. Thank you, Herbert.
Hey there, thank you for joining me. If you can, please consider supporting this channel so I can keep it going. It's a lot of work arranging all these amazing interviews. One of the easiest ways is just to click that join button and become a member of the channel. Thank you very much, and let's get brighter.